Good morning, students. Today we are going to see the limitation of Ellingham diagram. Okay, this is a very simple topic, but it's a very important topic. It asks in only the 2 mark or 3 mark question. Okay, it's a observation of Ellingham diagram, application of Ellingham diagram, limitation of Ellingham diagram is also it's a very important question. So only I give the separate video in this topic. Okay, okay, next now we are going to see the limitation of Ellingham diagram. In the limitation of Ellingham diagram, you have two limitation. Okay, two limitation. Now we are going to see the first limitation. In the first limitation says, so metal oxide reduced with the metal, it takes place or not. Okay, it is possible. Okay, the possibility is called as, already you know, the possibility is called as the feasibility. So the Ellingham diagram gives the detail about the feasibility of the reaction. Okay. So the particular temperature, the metal oxide reduced with the metal, it is possible or not says only the Ellingham diagram. Okay, but Ellingham diagram does not says about the speed or slow of the reaction. Okay, so it is not filled to tell about the rate of the reaction. So it is the first limitations of the Ellingham diagram. Okay, so it give the information. It gives the information about the thermodynamic feasibilities and not about the rate of the reactions. Okay, it is only give the reactions or feasibility or not. It is reactions or takes place or not only explain in the Ellingham diagram. It is not explain the rate of the reaction. What does mean by rate of the reactions mean? This does not explain the speed of the reaction. What speeds are going on? The reaction is speed reaction or slow reaction. The rate does not mention the Ellingham diagram. So this is the first limitation for the Ellingham diagram. Next we are going to see the second limitation. Second limitation, already you know the Ellingham diagram. This is the Ellingham diagram. This is the Ellingham diagram. In the Ellingham diagram, you have del G naught value. Del G naught is equal to RT ln P. It is not P. So it's a Kp. Kp means, so all Kp means all the values are calculated by Kp values. The Kp, the values indicate all the reactions are equilibrium. Already you know Kp means the equilibrium reaction. Equilibrium means the product or reactants are equilibrium. So it's the same reactant product. Actually it is not true. So all the reactions are takes place in the equilibrium reaction. So okay, but it is not true. But all the reactions are not equilibrium. Okay, but it is not assumed that these reactions are in equilibrium. These reactions are in equilibrium. So it is the big demerits. These are the limitations of the Ellingham diagram. Okay, first another, so assumed, this is assumed only equilibrium. Assume தான் பண்ணிருக்காங்க equilibriumன்றத assume, but surely is not explain the equilibrium. Okay, so this is the second limitations of the Ellingham diagram. So second limitation says it is assumed that, this is only assumption only, it is assumed that the reactants are in equilibrium with product, which is not true. அது வந்து true கிடையாது. உண்மையாவே as all the reactions are not equilibrium. Okay, this is the two limitation. First limitation is the reactions or thermodynamic feasibility is not explain the rate of the reaction. Okay, next reactions are, it is assumed that the reactants are in equilibrium with product, which is not true. Okay, so equilibrium assumption தான் பண்ணிருக்காங்களே தவிர அது வந்து உண்மை கிடையாது. Okay, this is the second limitation. Okay, next video you are going to see the electrochemical. We are going to see the electrochemical principle of metallurgy. I will explain the next video. So detailedly I will explain the next video. Okay, thank you, student.